3、2、1，开始。
Hello and welcome to our live stream at this hour. I'm Youyang in Beijing, and today is China's Space Day. That is why we are coming here to the China Science and Technology Museum to exploring the Tianhe core module as well as other models of China's space program. And so joining me is my colleague Zheng Yibing. Hello, welcome to the show.
Well, it's good to see you again, Youyang,
Yes,
because
course.
1 year ago we were here and do the live streaming about the Tianhe, the core module of China's space station Tiangong.
Well.
And today we come here again, but the feeling is a little bit different. Can you describe that?
And things different too. Dabing, what I want to tell you is that you mentioned the Tianhe core module last year, but what is behind us is totally different from what we see last year. Do you know why?
Please introduce to our audience.
Okay, let me explain that. Because this part is not really a model. That's exactly the engineering model of the Tianhe core module. It could be work as a replacement. That is to say, if the real core module has any problem, this one could be a replacement. So that is why it looks more tiny and more specified.
Yes, actually, we can see this one is pretty similar with the real model, and the similar with the one flying in orbit for some 400 kilometers above the Earth, from this side to this side, and to the working side of the Tianhe core module. But we need someone audit advisor to explain more details to us. So
let's welcome Professor Yang Yuguang joining us. Hello, Professor. Thank you so much for joining us.
Professor.
We're quite familiar with you, right?
Okay,
Hello,
so,
everybody.
Yes, we will do some kind of the introduction. Mr. Yang Yuguang is our old friend and best friend, especially in this field. He's a vice chair of the International Astronautical Federation Space Transportation Committee.
I think
To welcome.
Our audience is quite familiar with you. Welcome, Professor Yang.
Yeah, can you say something to us about the Space Day of China at the very start?
Well, hello everybody. That today is the National Day of Space Flight of China. I recognize this as an employee from the China Aerospace. I recognize this not only a recognition of the state, but also I recognize this as the recognition of the whole society, of the common people, to the achievements and the importance of this space field. Thank you.
Well, that's totally different from what we see here. But Professor Yang, tell us the general introduction of this engineering model. Why it's different?
Yes. As you have already mentioned, it is the engineering model of China's space station. So, that's the flight model, or the real one, is just orbiting the Earth. It was launched by the Long March 5B carrier rocket last year. So this is the engineering model. Usually, during the manufacturing process, we use multiple engineering models. For instance, this one is a structural model, which means that it is used for the mechanical test. Yes, exactly. So whether the forces act at the station either during the launch vehicle flying or in the orbit, so we'll test everything about that. So it will be also usually also for this kind of test we have some conditions called the qualification test and also acceptance test. For the qualification test, we will use a more strict requirement to this model. So you can see. First, I will show you something interesting. Do you see that that spheres?
Which one?
The spheres at this compartment.
The surface of this compartment?
Yes, the
Okay.
spheres. So that is have a very close relationship to you. So do you know where do you come from? Which company do you work for?
For CGTN.
Okay, but the CGTN also belongs to this. Belongs to CMG. Yeah, you know that CGTN is a subsidiary of CMG.
Yes.
So this is CMG.
This is CMG.
This is
So-
China Media Group. Oh, no.
This is
It's a joke. This is the control moment gyroscope.
okay.
The control moment gyroscope is used to control the attitude of the spacecraft. Actually speaking, of the whole station. You know that we also have thrusters at the surface of the station. But with the thrusters, usually we only in the circumstances for a rapid attitude control of the spacecraft. Because with the thrusters, we need to use the propellants. And the propellants is very, very valuable. But for the common attitude control, we use the control moment gyroscope. You see, that only use electricity. you know that with the solar panels, we have, theoretically speaking, we have infinite electricity. So in most cases, for changing the attitude of the whole station, we use these control moment gyroscopes.
Yes,
Okay, so right over there, that's the control moment gyroscope.
And also, you know that in the future, we will just in this year we will launch the Wentian module, and also Wentian have additional control moment gyroscopes to be a backup of this control moment gyroscope, because you know that's the core module or the Tianhe one is in charge of the whole station. The orbital control, the attitude control, the electricity, the power supply, and also the data handling. But in most cases, the Wentian module can also act as a backup of the core module.
Yes,
Well, that's interesting.
Professor
Definitely not
Professor Young gave us the full picture of the China space station, and especially the core module and also the cargo ship and manned spacecraft. And also at the current time, I have the big picture, and we can go around this model. We can go there to see
Let's come
the
and
details.
see.
So before that, I want to ask you the question.
Yeah?
So 1 year ago, they did a very interesting package for all the audience for CGTN.
Okay.
But I'm just wondering, when you enter the core module, the model of the core module,
Yes,
what's your
yes.
feeling, please?
Well, it's really interesting. It's totally different from what we see in ordinary life. For example, well, actually, when entering the model, I can see the two parts of the Tianhe core module. The first part is the thinner part, and where the astronauts living there, and they have sanitation places. And of course, for the thicker parts, I think it's much more important. That's for where they did the experiments. So, Professor Yang, you got an idea for the thinner part and the thicker part. Why they have different names and why they're totally different?
Pardon, you mean the
Yeah, the
docking
living
part?
area in the Tianhe core module is called thinner part, and of course the experimental part where they launching the experiments is called the thicker part because it's larger, of course. So why they made some difference between these two areas, and why the living area is much smaller than the experimental area?
Well, you see that, as I have already mentioned, the core module is used mainly for the charge of the whole station. So you can see that on this, so the core module or the heavenly harmony, the Tianhe, is composed of three parts. Look, this one looks like a sphere. This is a node. And also this small cylindrical compartment and the big cylindrical compartment. So what you mentioned, the living quarter, is just inside this small cylindrical compartment.
yeah.
There are 3 bedrooms and the toilet.
That's so good.
Also, you can see that there is a very round window on the side.
Oh,
So
yeah, I
that
saw
is
that.
just this window is also just inside is the bedroom of the astronauts. So the astronauts can enjoy the beautiful view of the Earth in their bedroom.
Can they
And
see the
also-
stars like what we see on the Earth? It's like tiny light spots like that. If they say the stars, or much bigger than what we saw here on the Earth.
Not bigger, but the star will be more clear and more bright in the outer space. And also, you see that at this compartment, we can have the solar panels. Not here, but we can see the drivers. We call that SADA, or the solar panel drive assembly at this part. We should also emphasize, although you know that China use similar modular design like the Mir space station, which is belong to the 3rd generation space station. But our technology, usually we use advanced technology so that have the similar performance of the 4th generation. As I have mentioned, the solar panels, we use the triple junction gallium arsenide solar cells. So that have almost the highest efficiency, which can provide much electricity to the station.
So many high tech on the core module. So here we have some.
The souvenir and the models here.
Yeah.
And please, this is a toy, but we can see the general picture of the China's Tiangong station.
right?
Yes, it's very interesting. There's more than 500 parts, and use at least 3 hours to assemble it. So, Professor, can you show us what's the model it really is, and also at the same time, I got this one. This is a souvenir from the Aerospace magazine, and we can take a look at this.
Yes.
Wow.
Yes, and this one is more clearer. So, Professor, can you show us? Because we see this is a core module of the China space station. And this is Wentian, the docking part, and the Mengtian laboratory spacecraft. And also this is Tianzhou cargo ship, and also the Shenzhou manned spacecraft. And also we can see there's the laboratory part of the 3 and number 3 and number 4. So can you give us a little description to this?
Well, you see that this is basic configuration of China Space Station, which means that by the end of this year we will complete the construction of the station, and we will have 3 modules: the core module, Tianhe, and also the Wentian module, the space laboratory, and also another space laboratory, Mengtian. So these are the basic configuration of the station, 3 modules. But in the future, as you have already asked, our station is also extendable. You see that this shows the extended version of the station.
So that is why we have more laboratories.
So this is a core module. This is Tianhe, and this is Wentian, and this is the Mengtian module. But in the future, you know that maybe after operation for several years, maybe for 10 years, we can launch another core module, or secondary core module, this one. To the station, and with this module, you can see we can have more docking ports and berthing ports to the station. So that is the reason with this module connected to the station, we can have additional module. The more important thing and interesting thing is, it is possible that in the future, some of these modules made by another country. You know that we adopt
international.
Exactly. So that's the possibility. So that will be the highest level for international cooperation based on station. You know that we China not only recognize the Tiangong space station as a national laboratory on outer space, but also as a very, very important international cooperation platform. So in the future, you know that there are already 9 experiments from 17 countries chosen by the China Manned Space Agency and the United Nations Office of Outer Space Affairs. So maybe by the end of this year, the experiments, the equipment will ship to the station by the maybe Tianzhou 5 or other cargo spacecraft and performed by the astronauts. We can very frankly see this kind of joint experiments. But in the future, also the foreign astronauts can visit our space station via the Shenzhou spaceship. Also, the third level will be the visit of the spacecraft from other countries. Okay. And finally, the module from other countries.
Okay, so I got questions. And also, ladies and gentlemen, welcome to CGTN show, a live streaming from China Science and Technology Museum in Beijing. Me and my colleague Yu and Professor Yang are going to here to explain how does China build its own space station. And now we're next to the very core module of the space station, and also we have the general map of China's plan to build its own space station. So if you have any questions, please leave your message to us, and we'll just let Professor Yang to answer all the questions. So let's come a little bit closer here. This is Chinese description to the China space station and the recent missions, and we want Professor Yang to explain to us. So this is the core module of the space station was launched in April 29, almost a year ago, from the China's Wenchang spacecraft launch site in China's Hainan province. And also the core module and also the cargo ship is flying in orbit for a long time. And the next mission would be the Tianzhou 4 cargo mission. And because just a few minutes ago, I asked the question to Yu Yang. Last year, she did a very interesting package about her feeling inside the core module. And now we see during the Shenzhou 12 and 13 mission, there are 3 astronauts or tachonauts have been in the orbit. They are respectively the first, the Shenzhou 12 is Ni Haisheng, Liu Boming, and Tang Hongbo, and then the Shenzhou 13 mission, Zhai Zhigang, Wang Aiping, and Yi Gangfu just returned back to Earth. So this question is, could you describe your feeling again? It is the space very natural inside the core module.
Actually, when we know that the two crew had come back to Earth, and of course that's marking the completion of China Space Station's technology verification phase. That means in this phase we have launched 6 launches, and the first one is about Long March 5 rockets, and the second one is about the core module. So in the last year, in May, that is the first launch of Cargo 2, and of course in these, for the Shenzhou 12, they were launched in last June, of course, and they stay in in orbit about 3 months, and they have carried out
183 days.
Indeed, wow, good memory. So they launched several testmen because they are the first inhabitants of the Tiangong, of course. And for example, they have do some installation work. For example, they have installation their sanitation part, and living parts and sleeping parts, all this area. And more than that, they have also carried out some extravehicular activities. That's so important, and they have carried out twice. So here I would like to ask Professor Yang.
Professor Yang again, and then this is to continue the question to Yang. This is because we have the different teams. For example, the Shenzhou 12th manned mission, there were 3 astronauts. 13 mission, another 3 astronauts. And then for the Shenzhou 14 and the 15th, the next 2 missions, there will be another 2 teams of 3 astronauts. So in the future, I'm just wondering how many astronauts could live inside, because Yang just stayed there for a couple of minutes, and she shared the feeling with us. But in the future, when the Chinese space station was completed, the construction of it is completed, how many astronauts could live inside the space station?
That we can already see that at this station we have a core module, and as I have mentioned, in the small cylindrical compartment, there are 3 bedrooms. And also in the future, after the Wentian module comes into orbit, as the Wentian has more backup functions of the core module. So it is very interesting. Wentian will have another 3 bedrooms.
Wow! So at the same time, there's going to be 6 astronauts.
But that the design of the Tiangong space station for long duration residence, usually every expedition team has 3 crew.
Why we have 3 members in the
because that is limited by the environmental control and the life support system. For any crew long-term residence in space, we need water, we need food and other resupplies. So if we double the crew scales, that will need more resupplies. So 3 crew will be a better choice for us for either a balance between scientific research and also the expenses. But as you have already asked, for a very short duration, just during the changeover of the different expedition teams for a short period, either maybe 1 week or 2 weeks, we will have 6 astronauts on board the station. So let's look at this model.
Yes, Professor.
At this note, at the front, we have a docking port. And at the bottom, we have another docking port. So it is possible with a cargo ship docked to the rear docking port, but we can also have 2 Shenzhou spaceships docked simultaneously to this node. So at this moment, we can perform the changeover of the different expedition team. But that's only for a very short period. I should also emphasize that the changeover in orbit will have the highest efficiency, because that we do the scientific research continuously. Just before the end of one expedition team, usually most of the scientific research cannot be ended. So at this moment, if we can have the other crew on board, and we can deliver the tasks face to face. So that will be very, very necessary for us.
Okay, Professor Yang, I got another question, because you mentioned about this is the docking and the parking areas. So for the next mission, for example, the Tianzhou 4 cargo ship launch in May, I'm just wondering, on either side of the core module, it could be docked, or on just one side?
Just several days before, just after our Shenzhou 13 crew came back to the Earth, you may notice there is the news that the Tianzhou 3 cargo ship has undocked from the rear docking port and redocked again to the front docking port. So that is to free the rear docking port for what you mentioned, the Tianzhou 4 cargo ship. And then the Tianzhou 4 cargo ship will dock to the rear docking port, maybe in May.
Both sides?
But also, you know, that there are other things we consider. You know, that the Tianzhou 4 cargo ship not only brings most of the resupplies for the Shenzhou 14 crew, but also brings the necessary equipment for the formal construction of the station. So the Shenzhou 14 crew and also the Tianzhou 4 cargo ship will be the most critical part of our construction. So after the arrival of the Shenzhou 14 crew, you know, that the Shenzhou 14 crew have no choices but to dock to the Earth-facing. This is called the nadir, or the Earth-facing docking port. So only can dock to this port because you know that.
Because at that point, Tianzhou 3 and Tianzhou 4 together docking in for the core module, right?
And after that, as you ask, will be the undocking and the deorbiting of the Tianzhou 3 cargo ship. This to free the front docking port for our Wentian and Mengtian. And usually, you know, that the Wentian and Mengtian are also can fly independently. But to connect to the station, they don't have other choices but to first dock to this front docking port. And then,
is that what Yibing did in the space about the Tianzhou 2?
Exactly. Use the robotic arm to change the position of the Tianzhou 2 from the front docking port to the side berthing port. So this is, I should also mention that this is a backup measure. To construct the station, usually the main measure will use the so-called transposition mechanism to transfer the modules from the front docking port to the side berthing port. But if that goes wrong, we will use the robotic arm as a backup measure. And with the help of the robotic arm, we can move the Wentian and Mengtian from the front docking port to the side berthing port.
Another question is,
it's from
our viewers. Please.
Okay. So we got a question from our viewers. Is will you allow the African citizen to the space station? Wow, that's really a good question.
I think that's possible. You see that I have many African friends, those from Egypt, those from Nigeria, and also I just attended the global conference on emerging countries in space field in Morocco in 2019. So we have many friends from Africa. And also, you know that China opened its station to any country around the world. So technically speaking, the astronauts from Africa can also visit China's space station. But before that, they must be chosen and also they must be trained in China.
Why they must be trained in China?
You know that for any space flight missions, still manned human space activity is very, very risky. So they must be trained for all kinds of operations, including the piloting the spaceship and also they can survive in emergency cases. For instance, if in an emergency landing, the spacecraft will land in forest, maybe they have beasts, and maybe landed in the desert. They must can survive and until the rescue team arrive.
Well, so this is a completely international cooperation, and not only within China, but also with other countries. Just like you mentioned, we have the backup plan for the expanding of this space station and in cooperation with other countries. So I have the question because I witnessed the returning of the astronauts from the Zheng Satellite Launch Center, the landing site here in the airport in Beijing. And I noticed that because they mentioned one question, a very important question is this robotic arm. Because during the verification period, this is one of the most important things. So I want you to explain to us, to our audiences, how important is that? And China did what kind of the breakthrough in this area? And at that point, I need to go up to the fourth floor. Because we're going to get to the second side of this live streaming, and Yu Yang and Professor Yang, you're going to stay here. So see you in a minute.
We will catch up with you later, just in some minutes. See you later, Yibing.
See you later.
See you later.
See you later.
So Professor Yang, Yibing left us a question about how important the verification phase is. Tell us about that in detail.
Well, you know, that's the crew transportation, the EVA, and also the rendezvous and the docking are called the three fundamental technologies for human space activities. Either you want to build and operate a space station, or you want to have human missions to the moon, you must master these technologies. So we master these three technologies via the Shenzhou 5 to Shenzhou 10 missions. But that's the fundamental technologies, not all the technologies needed. So that is the reason we have the technology or key technology verification phase for our whole space station program. As Mr. Zheng Yibing has already asked, the operation of the robotic arm will be very necessary, not only necessary, but also very important for the construction of the China space station and for the future scientific research. You may notice that during the 4 EVAs performed by the Shenzhou 12 and the Shenzhou 13 crew, one of
They all use robotic arm.
yes, they will use the robotic arm to aid the astronauts to move very fast from one point to another. And also, the robotic arm, with the help of the robotic arm, they can not only bring themselves to one certain position, but also bring very large equipment. So that is very important for the future installation of the devices outside the station, not only for the devices to operate the station, but also for maybe some kind of scientific research experiments outside the station.
Understood, Professor Yang. Talking about the robotic arm, but it's quite strange. I didn't see it on this model. Why?
Yes. During the launch, it will mount it here at the bottom. Look, at the bottom.
Usually it should be on the bottom of the
Yes.
core module,
So
right?
during the launch, and also you may notice this one. So
Yeah.
this is an adapter.
Adapter?
This is an adapter for the robotic arm. The robotic arm is like the human arms have 3 joints, but you know that the robotic arm can move along the station, along the surface of the station like a worm. How can they do this? Because there are multiple adapters. So they can connect its end to this adapter, and then the other end will move on to another adapter. So that is the reason it can move along the station. And also, you know that actually speaking, we have 2 robotic arms. One is a big one, which can moving objects up to more than 20 tons of the mass. And also we have a smaller one for very precise operations. You know that the 2 arms, the interesting thing is it can connect together to form an even bigger arm with a total length of about 15 meters.
So it's quite PC. We can't see the robotic arm on this model, but of course we still see some handles here, Professor. So what are the handles used for?
So you know that for the operations of the our astronauts, then the first thing first is to keep them safe. You know that we use the safety belts. So at any moment during the EVA, we must have a hook fixed to this handle. So that is to keep the safety of the astronauts, because without that they will float away and they will be very dangerous. Because,
Understood.
you know, the life support system of the EVA spacesuit can only support to maybe 8 hours.
8 hours.
They must go back to the station.
Understood. So if you take a look at the handles on the surface of the core module, that's used for the extravehicular activities. So if the astronauts to launching their spacewalks, they need to handle these kind of handles. It's very important for their safety. So Professor Yang, I got another question, because we have the Tianhe core module and its design lifespan is 10 years. So that's made us quite curious why we have a kind of lifespan for this core module or for Tiangong.
Actually speaking, every spacecraft or even everything have a lifespan. So the designed lifespan is 10 years. That is depends on the you know that the spacecraft orbiting the Earth in outer space in the radiation environment. So the electro devices have the limit of the what we call the total dose effect. So yes, total dose of the radiation they can receive have an upper limit. So some of the design of the equipment is based on this limit, and also you know that the structure have a limit, and also the you know the propulsion system and also other critical system have a lifespan. So but that's the only designed lifespan of our spacecraft. Usually to ensure its safety, we have a design margin. Usually for ensure the safety, the design margin is bigger. And with this, generally speaking, we can prolong the lifespan of the spacecraft for maybe 15 years or even 20 years. So it also the same situation, you know, that in the operation of the Mir space station and the International Space Station, they worked much longer than their designed lifespan. So we can also expect that our Tiangong space station, although the designed lifespan is 10 years, but we can expect it can work longer in outer space.
So Professor Yang, here we have another question from our viewers, and they're quite curious about our missions here, of course. So they're asking, will there be any joint missions between China and Russia to the Tiangong space station?
Well, this is quite possible, but for joint mission have very different styles. We have already discussed about joint experiments. That will be the easiest and also the most frequently seen joint experiments, which means that the other country provides and designs the experiments, and the equipment will bring to the station by the Tianzhou cargo ship, and the experiments will be performed by our Chinese astronauts. So that's one style. Another style is the visit of the astronauts from other countries. So it is also possible for the cosmonauts from Russia to visit our Tiangong space station via the Shenzhou spaceship. So that's the second level of cooperation. It is very interesting. You know that a German boy called Matthias Moria. He is now orbiting the Earth in the International Space Station. He will go back soon. And also another Italian girl called the Samantha Cristoforetti.
Oh, she's quite popular, yes.
Yeah. Samantha will visit the International Space Station within just in this month. So it is very interesting that both this boy and this girl were trained in China several years before.
Wow.
In Shandong, in rescue training at the oceans. And the more amazing thing is that both can speak Chinese. During the interview.
Wow, are they fluent in Chinese?
Yeah. Although I met Matthias several years before in Bremen, but I don't know this. At that moment, I don't know that he can speak Chinese.
Wow. So have you ever communicated with them in Chinese?
I believe so. So also, you know that Mr. Ye Guangfu, the Shenzhou 13 crew, also, several years before, he attended a training in Europe. This training is organized by the European Space Agency. So Mr. Ye Guangfu can also speak English well. So it is possible for the visitors from other countries.
Gotcha, understood. Well, we are quite hot here in our live streaming, and we have another question from our netizens here. And they're asking, will there any collaboration between China and New Zealand in our space station program?
Well, New Zealand is very, very active in space field, especially, that's the launch of the Electron rocket, although that is a rocket designed by a US company, but the launch site is in New Zealand. So I also have many friends in New Zealand space sector. I believe that in the future, it is also quite possible, as I already emphasized, that China's space station is open to the whole world. So to my view, maybe the joint experiment will be the most easiest for us to achieve.
Wow. Gotcha, understood. And so here today we are in the first floor of the China Technology and Science Museum, and we are exploring about the Tianhe core module. Actually, what I want to mention here is about the engineering model of the Tianhe core module. That's totally different from what we saw last year. So that is why we have given so many details about this Tianhe core module today. For example, we have seen the berthing port, and we're also seeing the docking ports here. Yes. And one important thing is we have to distinguish what is the berthing port and which is the docking port. It's totally different from the two things. And also we have introduced you about the Wengtian and Wentian, the two laboratory modules. So it's quite interesting. And I think at this spot, my colleague Zheng Yibing has been ready. At the fourth floor, we could see so many interesting things at the fourth floor. And he's going to bring us for the exploration of the fourth floor about the more modules about China's space station program. So Yibing, talks to you.
John, in a minute. Thank you so much for the very interesting live streaming from the first floor. We're going to join each other in a minute. Now I am at the fourth floor of the China Science and Technology Museum. And now we could see this area has a much bigger picture, much bigger exhibition about the China's ambitious plan of the space exploration. The first part is China's Beidou satellite navigation system, and also we have the remote sensing imaging system. Also, in the future, there would be the rovers of the Mars and also the exploration to the moons. But generally speaking, today is really special because today is China's 7th Space Day of China here in this country, because so many people across the country are celebrating this day. They go to the different venues, for example, the museums and science and bases in China, to experience, to feel excitement of the space program they brought to them. Take a look at this in distance. we got another live streaming part because the people, the expert and audiences in China are witnessing those people are discussing about the dreams in the space about the Chinese people. And just a few minutes ago, we mentioned about the international cooperation, and also on the first floor of the China Science and Technology Museum, we have the core module of China Space Station. And we have the explanation from Professor Yang Yuguang, and now they're coming to the first floor. And before that, let me do a little bit introduction to this part. This is a shining satellite and the 3D imaging of the Earth and the orbiting of the satellites. This is pretty amazing and very interesting. And also, we can take a look at another part. And next part is about the rockets, because we mentioned about the different missions of China's space program, especially the 6 flight missions for the China's space station Tiangong, and we come a little bit closer to that. Hi, Youyang, Professor Yigong. Okay, so we join each other here. Professor, I got another question is, because here we can see a lot of the rockets. And the model is simulating the different phases of the rocket in space. And also there is the rocket, and here is a model of the launch site. So could you tell us something about the Chinese rocket, the history of that? Before that, Youyang would make a discussion with you. I will make another picture for that. So
sure, thank you, Yibing. Well, so Professor Yang Yibing left us another question. Of course, tell us about the history of China's rocket development.
Okay, China's carrier rocket have a very, very long history. You know that our space industry starts from the 1950s. At that moment, we just developed our first carrier rocket called the Dongfeng 1. You can still, yeah, exactly. You can still have the original copy, one of the original copy of this Dongfeng 1 in the China's Military Museum. And also in the 1960s, we developed our Dongfeng 4. The Dongfeng 4 is a multi-stage rocket with that. So, but that's a 2-stage rocket. So we end the 3rd stage, a rocket solid motor at the top, to form a 3-stage rocket, which will be the very famous the Changzheng or the Long March 1.
Yeah.
So just in April the 24th of the 1970, we launched our first satellite, the Dongfang Hong first. So that is
quite famous.
Because today is the National Day of Space Flight of China. But that's only the start. The diameter of the Long March 1 is only 2.25 meters. So just several years later, we developed a bigger one called the Long March 2. The Long March 2 has a diameter of 3.35 meters. So there are many derivatives of the Long March 2. You see that we use the Long March 2 rocket to launch the first retrievable satellite of China in 1975. And also, there are many derivatives of the Long March 2 rocket. For instance, we use another derivative of the Long March 2. Long March 2 is a 2-stage rocket. We add the 3rd stage and call it Long March 3. We Long March 3 to launch the first geosynchronous or the geostationary satellite of China in 1984. And also, we use the Long March 3 to launch the first international payload satellite from US called the Asia 1 in 1990. So that's the first time of China. Okay. And also you can see this huge rocket. Is
the Long March 2F.
Professor Yang, so I know that you have a lot of the interviews to so many astronauts and the astronomicists across the world. And you even gather a lot of souvenirs. But today, the second souvenir I want to show to you and our audiences, this is another scroll. But I just want you to guess what is this?
Wow!
Is this a scroll? This is a whole picture of China's development of its rockets,
okay.
even the future ones. So Our video cameraman could face on the Professor Yang, and this one can give the details of that. So, Professor Yang, can you show us what's the development of the evolution of China's long march family?
Yes, exactly. So you can see that this picture shows the past, the current, and the future of our China's carrier rocket family. As I've already introduced the Long March 1 and also the Long March 2, and also the derivative of Long March 2. The Long March 2F is used for the launch of the Shenzhou spaceship.
The Shenzhou spaceship.
Yes, it has two derivatives. One is to use the launch the crewed spacecraft, and also one is to use to launch such as the Tiangong 1 and the Tiangong 2, because during the launch it is not crewed, so it do not need an emergency escape system. So that's
the emergency escape system.
The emergency escape tower.
That's especially for manned spacecraft.
Yes, exactly. So that with this help, we can increase the reliability or the safety for astronauts from 97% to 99.7%. So that's very important. And also, the Long March 3 and the Long March 4 series also belongs to the old generation. These are the old generation. The features is that for the first stage and the second stage of these launch vehicle, we use what we call the hyperbolic propulsion system, which means that the propellant is in room temperature. We use the UDMH, or the unsymmetrical dimethyl hydrazine, as a fuel, and use the nitrogen tetroxide as the oxidizer.
So, Professor Yang, I want you to explain a little more about the recent rockets, especially for the cargo ship, the Fat 5, and also the Long March 7. So these two.
So, from the Long March 6, we can say yes, this one. So this one is the first new generation launch vehicle of China, and then comes Long March 7 series and Long March 5 series. So these new generation use environmental friendly propellants. They use that the UDMH is highly toxic and NTO is highly corrosive. But these launch vehicles use the kerosene as a fuel and use the liquid oxygen as an oxidizer. So these are much more powerful, but also very environmental friendly. And the important one is, as you mentioned, the Long March 5 and the Long March 5B. The Long March 5 is used.
Why is it called the fat boy or the fat girl?
Yeah, we have so many different names
in our
here.
professional field, this is called the aspect ratio. The aspect ratio is this length compared with its diameter.
Okay.
You know that you call this fat 5 because the aspect ratio is rather low, because it's much more bigger diameter, but comparing its length, it's bigger. So the two derivatives all belongs to Long March 5 family, but the Long March 5 is a 2.5 stage rocket, so it is used to launch very high altitude payload. For instance, our Chang'e lunar probe and also our Tianhe 1 Martian probe. So we use all very heavy geostationary orbit payloads.
Here's the model of
Yeah,
the rocket. We can do some example.
We
Can
have
you show
some
us
example here.
what's the specific part it is?
So,
For example, they're showing the different stages of the rocket.
You can see that this is a Long March 2F. Long March 2F, we can. Oh no.
Yeah, we can directly separate
Okay.
it. That's
Okay. So the Long March 2F is what we call the important thing is it is a human-rated launch vehicle. Human-rated launch vehicle means that it is safe enough for crewed missions. The reason you have already asked, it is because the two things. One thing is that we have an emergency escape system, like this. Yes, with the emergency escape system. And also we have the malfunction detection system on this launch vehicle. And the Long March 2F is also a derivative of the Long March 2. So you can see the core stage has a diameter of 3.35 meters. It is very interesting because we can make bigger ones, but this is limited by the tunnels, by the size of the tunnels of the railway.
Okay.
So that is the reason we choose this diameter. And also it has 4 side boosters. Each has a diameter of 2.25 meters. So we have...
the booster too.
Yes. Exactly. So we use 4 YF-23 engines at the core stage and the similar engines for each boosters. So the liftoff thrust is more than 600 tons. Okay. So that is first stage. And also, sorry.
now this is assembled state, and we can do some kind of a launch.
Yes, here, and
Yes,
audience
it's
gonna see
almost
the launch
ready.
site, how does
And
it work?
there's a launch pad.
Yes.
So, Professor, can you
Let's have a try.
and
So,
for us,
so
then
first
we'll
will
see.
be a countdown. Okay, so the rotational platform of this launch complex will open. So let's go.
Let's try it.
Oh no.
But actually, I think we need to do a competition here. Yeah, how to operate this launch site. Is that because we haven't did a competition?
Yes. Excuse me, sir. Can you show us? Because this one is really, really amazing. I played it some.
Okay, I will introduce something about this launch complex.
Okay.
You may continue.
Okay.
You may continue.
Okay, so you can so this launch complex in the Jiuquan Satellite Launch Center. So
You must come to Zheng earlier, I guess.
Yes. Year 2013.
but the real color is in blue, I believe.
Real color is blue.
It is blue, and this launch complex is very. So
Friendly.
so just before the launch, will open all the rotational platforms, and also, but after that there are also rotational arms connected to the vehicle, because we know that just before the launch we have cables to connect to provide the electricity, and
Yes,
also.
Professor, this lady, this is Meng Yao, is the operator here at the launch pad, and she could also operate on this launch pad, and she's assembling the parts.
Do I need to compete with you? Or, okay. So now we're doing a competition between me.
Yo Yang and Meng Yao, they are both operating on the launch pad. They have to assemble the parts of the rockets together. Professor Yang, what's the type of this rocket?
As I mentioned, this Long March 2F is a human-rated launch vehicle, the only human-rated launch vehicle of China, but also it belongs to the old generation. So it is a 2.5 stage rocket. Both the first stage, the core stage, the boosters, and also the second stage use the hyperbolic propulsion system. Use UDMH and the NTO as a propellant.
Yes.
And also the diameter of the core stage is 3.35 meters. And for the payload fairing, there are two configurations.
Okay.
So for the Shenzhou spaceship, the diameter of the payload fairing is about 3.8 meters.
Okay.
But for launching the Tiangong 1 and the Tiangong 2 laboratory, the payload fairing will be 4.2 meters bigger.
They are successful. It's successfully operating, and the launch is about to begin.
So you should also notice that just before the launch, not only the rotational platforms will be opened, but also we will perform many critical checks about the launch vehicle itself. As you know that the rotational arm is opened. But you can also see that still the rotational arm is still close to the vehicle because we have cables connected to provide the electricity and provide the checking of the monitoring signals and also send commands to the launch vehicle. Just before the launch, the rotational arm will also be open and also all the cables will be unplugged from the launch vehicle, maybe several minutes, several seconds before the launch. And also there is a tunnel inside this tower for any crew, ground crew, or for the astronauts in emergency cases. They can go down to the underground protection, with this tunnel.
Yes.
Just inside this tower.
Yes. So this year we're going to see the 3 different flight missions about the Tianzhong cargo ships and Shenzhou manned spacecraft and launch, and also the Mengtian and Wentian laboratory lab, the launches. So this is a 40 seconds countdown.
So this is what mentions the open of the rotational arms. And all the cables will be unplugged from the launch vehicle.
The red one is rotational arm, right?
Yeah.
And you are a good commander. You did a very good job. So tell us the feeling of assembling that different parts.
Okay, thank you, Debbie. Well, see, 3, 2, 1, fire.
Ignition.
See, it's over there, it's lighting.
So the 8 engines will be ignited simultaneously. Each have a thrust about 75 tons. So the total thrust is about 600 tons.
600 tons.
Yes.
Wow. Wow.
And the lift-off mass is about 500 tons. Okay, so more than 400 tons of propellants are inside this launch vehicle. So after liftoff, the first will be pitched over. Just turn the direction of the flight from a vertical one to a leading one. And then the second step will be the jettisoning of the... Okay, let's go.
Okay, so now we are successfully launching our Long March 5 rockets here. So this is the...
So the whole flight procedure is very complex. So as I mentioned, after liftoff, after several seconds will be the jettisoning of the emergency escape tower. So because you know that the altitude is already high enough, and also the aerodynamic forces is already low enough to ensure the safety. But still, at this moment, you know that there are still rocket engines on the payload fairing for continuous to act as a role if anything wrong happened. The rocket engines on the payload fairing can help the Shenzhou spaceship to abort from the rocket. And then at about 2 minutes will be the shutdown and also separation of the 4 boosters. So after that moment, about 150 seconds will be the separation of the first stage. Okay. It's over there. It's over there. So after that will be the ignition of the second stage. Second stage use only 1 main engine and 4 vernier engines. The main engine has a thrust of about more than 80 tons of thrust. Okay. And so just during the flight, after it is already high enough, will be the jettisoning of the payload fairing. So that's also an important point. At this moment, the astronaut inside can see the light.
Wow!
So this is also very easy. But still, at this moment, if anything wrong happened to the launch vehicle, we can use the engines on the Shenzhou space to separate to have an emergency abort from the second stage. And then, you know, that after about 9 minutes after liftoff, will be the shutdown of the main engine of the second stage.
Gotcha.
You know that, but you know, usually at this moment, the orbit or the trajectory is not accurate enough. So at this moment, as I mentioned, the 4 vernier engines are still working to adjust the trajectory very precisely. And then, if it goes already very precise, usually we use what we call the algorithm is a close guidance. And then the shutdown of the 4 vernier engines will means that it already goes into entering the right orbit. And then will be the separation of the Shenzhou spaceship, and then the deployment of the solar panels.
So now...
Separation of the ship and the rocket, right?
Yes, the separation and the deployment of the solar panels will mean the success. If the orbit is already accurate enough, it will represent that the launch mission itself will be a success. And you can see the big red screen in the Tianhe Satellite Launch Center.
Yes. During that time, the commander in the launch center would announce this is a success of the whole mission. And also, we have done some good questions. There's 3 questions from our audiences. The first one is Tiangong crewless now? Well, definitely. After 183 days in orbit, the 3 astronauts for the Shenzhou 13 mission have just come back to Earth. Yes, so because Yu Yang has mentioned a lot of details of that. Okay. And second question, Yu Yang, please share with us.
Yes, so we got our second question from a netizen is that this is so cool, and they have a working prototype. And they just say greetings, comrades, and they say congratulations for our works, I think. So how about the last one? Well, we'll finish with a display. Can I buy it for my house? Well, it's really a huge wish.
Do you have the sources of buying such models, or the rockets, or the spacecraft?
I don't catch your point.
Because buy this kind of
it's a model for because
space station when we
I think you can buy all kinds of these models on online shops. So there are all kinds of different scales. Very interesting. I also have one, but that's a Long March 5 model in my home.
Yes, this is my answer to this question. I already made my order online this afternoon. This is a
Really?
Chinese tachonaut with a flag in orbit, and also the rockets and also the spacecraft could be ordered online. The models.
Well, happy to know that.
Yeah.
And also
Maybe
very,
we'll do
very,
later.
very precise models of the either the carrier rocket and also our Tiangong space station. And the solar panels can even rotate.
Yes.
Oh, interesting. So
Another
talking about
part is Yu Yang has been practicing and doing exercise for the future mission.
Oh my God.
So you mentioned about the training here, the astronauts from other countries for the future space missions, not only for the space station. So what kind of the training the astronauts usually do in China? So we can move
Let's
on.
go. Let's go.
Okay,
So,
so
actually speaking, the astronauts, the chosen as the astronauts, has a very strict procedure. You know that they must be strong enough, so they can afford the violet vibration and the G forces during the launch and re-entry. And also they can adapt to the microgravity environment as soon as possible. That's very important for Earth. And also they must learn a lot of courses. For instance, the orbital dynamics and also the engineering, the design of the spacecraft, and also blah. So that is also very important. And they will have all kinds of tests.
Oh, okay.
Okay.
This is a
Re-entry capsule.
yeah, the return capsule.
Yeah.
But,
real return capsule.
The
I
real
think that's the
return capsule.
treasury of this museum, I guess they told me. But actually, if we take a closer look at this
before-
real return
before
capsule,
Before your training, you can take a look
we can
at
see
it.
the return capsule at least and make sure I can return here on the Earth. So, Professor, how about this? Give us some introduction about this return capsule.
So this is the re-entry capsule of a Shenzhou spaceship. You can see that this shape of the re-entry capsule is like a bell. So the height is about 2.5 meters in total, and also the diameter is about similar. So you know that the Shenzhou spaceship adopt a 3-module design. At the top is a orbital module, and then this re-entry capsule, and just below that will be a propulsion module. So that's the 3-module design of Shenzhou spaceship. And you know that during the re-entry, we only recover this re-entry capsule. So just you know that last week, our space girl Yibing and her colleagues just came back. So during the re-entry, we also the procedure is very complex. First, we will undock from the station, and then will be the separation of the orbital module and this re-entry capsule. After that, we will perform the re-entry insertion. So that means that from the circling around the Earth to the trajectory return to the Earth with the help of the propulsion system on the propulsion module. After that, we will separate the propulsion module from this re-entry capsule. We only recover this one. So usually that's the trajectory is along the African continent and go into the Asian and then go into our territory in Xinjiang, from Xinjiang, and then landed in the Jiutian Satellite Launch Center near the, it is called the Dongfeng landing site. And you know that you can see that the materials are in different color. So these are called the ablative materials.
Ablative material. That's
exactly.
not become burning.
So that will not burning, but will be vaporized because of the huge heat produced by the friction between the atmosphere and the vehicle itself. The high temperature will vaporize this ablative material, and it will bring the heat from the vehicle to the atmosphere to protect the astronaut inside. So, although the high temperature in our professional field, it is called a stagnation point. At this point, the temperature can higher than 2,000 degrees Celsius. So very high, just at the bottom. At the bottom, we have a very big heating shield. So that will work during the re-entry. So you heard of the word the blackout area. You know that because of the high temperature, the vaporized ablative material will be ionized and form a shield around the vehicle. And because you know that the ionized material can block radio waves, so at this period we cannot communicate with the vehicle, but still we can track the vehicle. So the blackout area begins at about the altitude from 80 to 100 kilometers, and will be ended at about 40 kilometers altitude. So after that will be deployment of the parachutes. Look, it's here.
So all there is the deployments of parachutes.
The chamber of the parachute is here. We have three. We have three parachutes.
How large the parachute will be?
The biggest one is, you know, that there are three parachutes. The biggest one is the main parachute. The total area of the main parachute is 1,200 square meters. Very, very huge. Yeah. So with as I mentioned, when it comes out of the blackout area, because of the aerodynamic drag, the velocity of the vehicle will reduce to about 200 meters per second. And then we'll, at about the altitude of 10 kilometers, we will deploy the parachutes. So first we will use a small parachute to drag the, what we call the de-acceleration parachute first. It works for several seconds to reduce the speed from the 200 meters per second to maybe 70 to 80 meters per second. And then will be the deployment of the main chute. The main chute will be reducing the speed continuously to about 6 to 10 meters per second. So after the deployment of the main chute, we will then jettison the heating shield at the bottom. So the retro engines at the bottom will be exposed. And as that, we will also perform a procedure to pipe out all the propellants inside the vehicle because it is toxic. And just 1 meter just above the land, the retro rocket will ignite, and then speed will reduce to about 2 meters per second. Yes. And just before that, we will also raise the seats of the astronauts to have another energy dumping procedure. Okay. So when touchdown to the Earth, the astronauts, the commander inside, will cut down the parachute to ensure safety, because with the wind, the parachute may drag the vehicle.
Indeed, it's quite
so that will be
important because
you know that this time, you know that the Shenzhou 13 landed vertically. That is because our commander, Mr. Zhai Zhigang, cut down the chute at the right moment. Wow. Because usually the vehicle will be dragged down by the parachutes.
Gotcha. So at this point, Yibing, I think you got more questions.
Yes, because we mentioned about this is the original thing of the returning capsule for the Shenzhou first mission back in the year 1999. And this year, on April the 16th, the Shenzhou 13th mission, that returning capsule has returned. And also, my question again about the Souvenir to other audiences, because someone said, this one is really interesting, so can I buy it? So I want to say I already ordered online for the Shenzhou 13. That miniature.
For the links?
Yes, the miniature of the returning capsule is only cost about $40. Wow. It's only cost about $40. Yes, the scale. The cheapest one is that. It's really brilliant. It's very. I just want to keep it for memory. Another question, share with us.
Yes, so we got another question from our viewers. It's what's with the weird gyro in the background? Which is the gyro? What's with the weird gyro in the background? What do you mean by gyro?
Gyroscope
is keeping the balance.
Yes, to attitude control. But I don't. But you know that usually, I don't know what he mentioned. But you know that usually we have gyroscope on our Tianhe space station. What I mentioned, the CMG, the spheres is similar like gyroscopes. But for the Shenzhou spaceship, usually we don't use the gyroscope to control the attitude. Look. Here we can see the nozzles of the rocket engines. We use these rocket engines
to... So if we come here, if your cameraman come here, you can see that in detail.
Also, there are another side. Oh, let's go to this side.
Yes.
Yes, so we can come there.
Let's see. It's blocked. So let's go to the other side. Yes, it's here. So look, these are the nozzles of the rocket engines. We just use these engines to change the attitude during the re-entry. This is because you know that this is a bell generally speaking, it's a cylindrical object. But you know that the
Looks like a bell.
yeah, but but we should emphasize that the center of its mass, or the centroid, is not at the symmetrical axis of this launch vehicle. It has a distance from the launch vehicle. From the bell. So with this feature, there are lift during the re-entry. With these engines changing its attitude, we can change the direction of the lift. So we use this measure to adjust its trajectory to the theoretical landing point. That is the reason why it is so accurate, because we have control. We call this semi-lift or semi-ballistic re-entry. So, but what mentioned also, although we don't have the control moment gyroscope to control its attitude inside, but we do have what we call the inertial measurement unit. They do have a gyroscope to measure the attitude or the angle very precisely.
Gotcha. So most of the function of the gyro is to measure and give specific attitude and angle of this returning capsule.
Yeah.
So at this point, after learning how I could come back to Earth, I could do some exercise, what taikonautes I do here. And then at this point, I think, Yibing, you could share some more questions from our viewers to Professor Yang.
Yeah.
So firstly, we are...
So, now
Yeah.
here for the fun part, Professor Yang and you, Yang. Yes, the training part. But we first are going to introduce Gong Yao from the China Science and Technology Museum. He's a really senior person here. He's an expert in this museum. So, Ms. Gao, I heard that for training on this device and in this gadget, there is a requirement of the two people with the same similar weight. So can you?
That is why we can do it together,
Yeah,
because
so
we
can
have
you
to
share
explain
with
here.
us
Yibing can
and,
joining us because he's much taller than me.
I cannot participate. So would you both participate in that and experience?
Sure. Well, thank you so much for joining us, and let's just do the exercise what taikonautes do for their daily training. Okay,
Yes.
so let's.
But I have a question.
Yeah,
I
please.
see you have skirt. It will turn to different direction.
Such
as
that's
upside down.
Our cameraman's
Yeah.
technology.
Yeah, so I
Okay,
don't
so
know
let's
if
have a
you're
try,
okay.
and
Okay.
because our cameraman's
Never mind.
technology-
Well, ladies and gentlemen, and my colleague Yu Yang and also Ms. Gao Mengwei are preparing for the training in the China Science and Technology Museum. And Professor Yang Yugan told me the training is an essential part for the space mission, especially the manned mission. And Professor Yang, how important this training really is?
Well, you know that the astronauts should be trained in all kinds of circumstances during the launch, during the in the orbit, and also during the re-entry. So so their feeling of balance will be very important for them. And also there are other trainings. For instance, as I have already mentioned, during the re-entry there are G forces, and also there are very intensive vibration. They will also use some kind of platform to simulate this kind of environment. So they must adapt this just before the flight. So that is to ensure the safety of the astronaut. I should also emphasize that you know that we not only need to train them in normal cases, but we also should prepare for the abnormal cases. So during very emergency re-entry, the G forces acting on the body of the astronauts will up to 8 to 10 G. So that means that the forces 10 times greater than their own mass. So you can see how serious is that.
We are making a preparation, and Professor Yang, I got another question. Is actually the video cameraman in front of us, this gentleman. He's from family from the working for the Air Force. And hi, Mr. Shen. Actually, we know that you have been working for such a long time, keeping the exercise, and especially your father is a pilot in the Air Force. And when he was a little, he told me he usually did some kind of these trainings in the base. So I'm just wondering, what's the difference between the Air Force and the space missions in such a training?
Well, it is an interesting question. You know, that's the first group and the second group of our astronauts were chosen from the Air Force pilots. although you know that's almost all the male astronauts were chosen from the fighter pilots, and also our space girl Yibing and Liu Yang were chosen from the freighter pilots. So the pilots has very good quality on their body and also their reaction to emergency cases. So this is very interesting, also very important for the astronauts. So so I think this is a good choice. Yeah, let's go.
Young,
Okay.
they are making the final preparation for this training.
Yeah.
And the training will last about 1 minute. And are you nervous? Are you nervous? How's it feeling now? Please fasten your belt, ladies and gentlemen.
Okay.
So we'll wait and see and how this training
So this
really
is,
looks like.
you know, you may notice there are different rotational axes on this device, on this equipment. So it will simulate the very similar case that will be possibly faced by the astronauts during the flight missions. So this is also a good, very good training. But in some cases, they will feel sick.
Yeah, they begin to.
Yeah.
to have this.
Okay. And also, the requirement to astronaut is that not only they can afford this kind of rotation, but also during this rotation, they can also operate or pilot the ship properly.
Wow. It is much different from a roller coaster. Much different.
Much tough.
Much tough.
So it is very interesting that maybe your colleague also knows that during the selection of the pilots of either the Air Force or the aviation flight, there are also this kind of similar tests to choose those ones who are not so sensitive to rotation. Because, as I mentioned, they must be able to operate and also piloting the ship, even the ship is in a fast rotation. They do have these kind of dangerous things before. You know that during the first docking mission of human being, the Gemini 8 mission, because of a malfunction of the spaceship, the Gemini 8 spaceship rotated very fast. And just before it is too dangerous for the astronauts, Mr. Neil Armstrong operated the spaceship properly to stop the rotation.
For such a long time,
No.
I just want to call you out.
It's so tough for girls.
How much tougher than I imagined. Yes.
I want to experience that.
Yes, I dare not to experience that.
Yeah.
You're just calling you out. Oh
brave,
my God.
So brave girls.
Very brave, actually.
Yeah. So next time, Miss Yu Yang can go to the training and the selection of the astronauts.
Yes, I heard that a lot of people,
Very
not
interesting
only...
that, you know, that's the first astronaut of Japan is a journalist, is a reporter. Yes. So that's also possible for you and your colleagues to go to outer space.
Yes, because when I was 10 years ago, when I watched the comic books from JAXA, on Japan Space Agency, I noticed that there are people also could apply for such a post as an astronaut. And also the gravity, the people as a doctor could also go into the space. And let me check her status.
So this is a very fundamental training of the astronauts.
Fundamental training, not the toughest one.
Not the toughest one.
Okay.
So rotation, vibration, G-forces are all must be faced by the astronauts.
Oh my God. Hi, Yu Yang. She looks good. And also the Meng Yao
very
also
great.
looks good.
Very great.
Yes. Ladies and gentlemen, here comes the important moment. They will be getting out of the training machine and then... you look good.
Yeah.
Yes, yes. There's nothing wrong with that.
Oh my God, don't ask me about the feelings. Well, actually, it's really sick.
Great job.
But I asked a question about Meng Yao. How many times have you tried this? But Meng Yao told me just once.
Just once.
Yeah.
Thank you so much.
How do you feel about it, Meng Yao?
Very sick.
Very sick indeed. And I think for girls it's quite sick enough and it's only 2 minutes. But for taikonauts, how many times for daily they're gonna train for this? 那对于太空员来说，他们每天或者他们的训练中会持续多长时间呢？
这个我也不是特别清楚，我觉得还是问专家吧。
Okay, we'll let this question to Professor Yang Yuguang.
You know that this kind of trainer, generally speaking, that the rotation during a normal flight will not be so intensive like this. But they must be, but they must prepare for the possible malfunction of the spaceship. You know that during, as I have discussed to Mr. Zheng Yibing, that during an abnormal case, even the Shenzhou space can rotate faster than this and longer than this. So you may lose your conscious. But you must have the ability to operate and piloting the ship just before you're losing your conscious. So they do have this, as I mentioned, they do have these kind of things before during the Gemini 8 mission. The first man to the moon, Mr. Neil Armstrong, saved the whole mission because he can operate the Gemini 8 spaceship properly before it is rotated. Because you know that if the rotation is fast enough, you can lose your conscious very, very fast.
In how many seconds? Or minutes?
Within several seconds, you can lose your conscious. So
Understood.
that is very, very dangerous. And the actual situation is during in 1965, during the Gemini 8 mission, the Armstrong is so calm that he used the propellants only permitted to use during the re-entry to stop the rotation. So that is the reason he can save the mission and save the lives of him and his crew member.
Well,
So at this point, through this training, we can find how hard and how important our astronauts are doing their
take
training.
years to become an astronaut.
And it's very, very, very hard to be an astronaut. And just as Professor Yang Yuguang mentioned, it's very important because at the key points, it's going to save their lives. So luckily, I've tried this training and tried how to be a taikonaut at this moment.
And we'll give it to us. And some questions from our audiences.
Did they ask about me?
Yeah, is it a very big gyroscope? And yes, it's a very big one. And also, this is mentioned about the CGTN taikonaut Yu Yang. Yes, congratulations, Yu Yang. You have done it. And also, some audiences asked you one question is about the next generation Shenzhou command module will be reusable. And is it much larger, bigger, and reusable?
Yes, you know that actually speaking, the technology verification phase have 6 launches. The first one is conducted in 2020, the maiden flight of the Long March 5B. You know that during the Long March 5B, the first flight mission, the major payload is the test vehicle of the new generation spaceship of China. Well, this spaceship is quite different from the Shenzhou spaceship. As I have mentioned, the Shenzhou spaceship has a 3-module design: the orbital module, the re-entry capsule, and the propulsion module. But the new generation has only 2 modules: the re-entry capsule and the service module. So with this design, but the diameter is much bigger, so the new generation spaceship can have 6 to 7 crew for a lower orbit mission. But for the future, it is also possible to have a mission to the moon. And for this new generation spaceship, because you know that it has 2 versions, one with a smaller service module, and the other with a bigger. For the bigger one, it has a bigger propulsion system, so it can be qualified to fly to the moon. Because you know that for the moon mission, the whole flight procedure is quite different from a low Earth orbit. For the low Earth orbit, look, you can see that at the bottom of the Shenzhou is the propulsion modules. The ability of the propulsion module is only about several hundred meters per second, or changing the ability to changing its speed. But for the future lunar missions, you know that when the launch vehicle sends the spacecraft to the trajectory, go to the moon, and when it is close to the moon, it must slow down its speed for about 800 to 900 meters per second, because without this procedure, it will fly by the moon. Will fly by the moon and not circle around the moon. So that is a necessary procedure. And for the return to the Earth, a similar procedure. They must change from a circular orbit around the moon to the trajectory, go back to the Earth. Another 800 to 900 meters per second. So the basic feature for the a spaceship to the moon is that the propulsion system will be much larger than a spaceship orbiting the low Earth orbit.
Wow.
So that's the difference. And also, you know that we have already discussed about the radiation belt. For the lunar missions, the spaceship will expose to the dangerous radiation, so it must be more robust to this kind of threat.
Yes, you shared with us a lot of the details inside about the China space mission, also the space program. And I think our live stream is going to end up here. But before that, so Yu Yang, our taikonaut here in the China Science and Technology Museum, can you share with us your feelings about the whole tour and the things you have gaining, especially on the training device?
Okay, gotcha. Thank you for asking me that. It's very special training here because actually for me, I have come to this China Science and Technology Museum for third time, and every time I had different feelings. For example, today we have more knowledge about the Tianhe core mill, the engineer device, and as for myself, and I have tried the training device. It's very special, very special. For although it lasts only 2 minutes, but it's totally special from what we do daily. For example, it's make me really sick, but it's only lasts for 2 minutes, and for me it's like 2 years. But at this point, I can totally understand how hard of taekwondo's training. And just as Professor Yang, you mentioned, well, they're gonna be selected from there. They need to be very strong so that they can be the taekwondos, and at some key points they can save their lives. So it's special for me, very special for me here. And today we have a special journey. And Professor Yang also joining us and explaining to us about our future experiments, of course, our future space program. So David, how do you feel about it?
I feel excited because I just experienced the 2 launches, and one is in Wenchang, the other one is in Jiuquan Satellite Launch Center. And very soon I'm going to the Hainan province to join another launch. But I don't know what time exactly really is, but I've got fully prepared for that launch mission, because this year in China there are 6 missions for the China Space Station. Professor Yang, before the end of the conclusion of this live streaming, can you say something about the schedule of this year's 6 missions?
Well, there is a news release conference just after the Shenzhou 13 crew go back to the Earth. So we will have, as you mentioned, the 6 missions this year. And just before the 6 missions, I have mentioned the the Tianzhou 3 cargo ship has undocked from the rear docking port and then turned to reconnect it to the front docking port. So it frees the rear docking port for the Tianzhou 4 cargo ship. And just in May, we will launch the Tianzhou 4 cargo ship. It will launch to rendezvous with the station and dock to the rear docking port. And then we will launch the Shenzhou 14 crew spaceship. The crew has already been selected, and then it will dock to the, as I mentioned, the Earth facing or the nadir docking port. So that's the combination. After that will be the undocking and the deorbiting of the Tianzhou 3 cargo ship. After that, that the front docking port will be freed. And in July, we will launch the Wentian module by the Long March 5B carrier rocket in the Wenchang spacecraft launch site. And it will dock the first to the front docking port and perform all kinds of tests. This phase is called I-shaped configuration. During this field, we'll deploy the SADA, or the solar array assembly, for the second time, because the very important feature is that the Wentian Space Laboratory has a SADA of 2-dimensional rotational mechanisms. So it will have a very huge solar array, and also brings a small robotic arm, 5 meters long, to the station. And we will test the operation of this small arm and the cooperation with the big arm together to form a 15-meter long combined arm. And also, after that, we will have the very important step to transfer the Wentian module from the front docking port to the side berthing port.
Yeah, so by that time, does that mean the completion of China's space
not
station?
this moment. Look, so what I mentioned, the launch will happen in July, and we will perform all kinds of tests. And in October, we will launch the Mengtian module. Mengtian module will also dock to the front docking port because it is already freed, and then transfer again to another berthing port. Only at this moment we can say that the T-shaped station has already been constructed. So
module and 2 laboratory modules. That's the completion point of the space station.
Yes. And after that, we will undock the Tianzhou 4 cargo ship, and then we will launch the Tianzhou 5 cargo ship to dock to the rear docking port. And then we will launch the final mission will be the launch of the Shenzhou 15 crew dock to the station before the end of this year, and we will meet the Shenzhou 14 crew in orbit, and we will turn over, as I mentioned, the changeover of the different teams in orbit.
At this point, can we see in total of 6 astronauts at the same time during this
historical moment for China Airspace, because it will be the first time we have 6 astronauts simultaneously in orbit.
Yeah, so
looking forward to that.
Looking forward to that, and because Professor Yang just mentioned from the press release that there's the crew members of the Shenzhou 14th and the 15th mission have been selected.
Indeed.
But I guess the Shenzhou 16 and 17, you will be one of them.
Really?
If you try harder.
I would love to have a try, but I'm not
So,
think I'm good
I'll
enough.
leave the microphone to Youyang and you, and to make the conclusion of this live streaming to our audiences of the CGTN.
For my encouragement, right? Because I
that's
tried that
so
training
good.
exercise. But I would like to say thank you to both of you, Professor Yang, you're going, of course, my colleague, Yibing, and you're going to the Wenchao launching site to see the launch of Tianzhou cargo ship 3 and charge 4 at this point. So good luck to you. And for us, we're quite lucky. We have this kind of special experience here. And this point today marks the 7th China Space Day. And of course, that is why we're coming here. And we're exploring all the models here, and with our Tianhe core module, and of course we saw some drone, and also we saw the Chang'e moon rover. So that is why we come to this museum to exploring all China's models using in this space program. And of course, Professor Yang gave us some in-details insights and introduction about the history of China's rocket development as well as China's core modules development. Thank you so much, Professor Yang, and my colleague Zheng Yibing, of course.
Thank you.
So at this point, and this is the end of our live streaming, and we're lucky to see and wish for you to of course communicate with us about your questions and leave out with messages. And we will see you next time, and keep staying with us on CGTN. Goodbye.
Goodbye.
See you. Bye-bye.